Okay, hello students. Here I would like to walk through some of the more problems, practice problem for lesson number 4.6, modeling. So these are all modeling problems to in exponential and logarithmic functions. So let's see, this problem is problem number 6. We did 1 through 5 in the classroom. So 1, 2, 3, 4, 5, I try to solve in the class, and this is problem number 6. As I promised, I'll make a video for this remaining 4, 5 problems, so that will help you to do the homework problem in your Cengage problems 6, 7, 8. So let me begin with this problem is about fox population. Sorry, yeah. So this is about the fox population in a certain region has a relative growth rate of 9% per year. So this itself is 9% per year itself is 9 divided by 100, which is 0.09. It is estimated that the population in the year 2013, that means if I do like this, in the year 2013, this is 2013, and which is considered as a 0 year. So this is T is number of years, and this is the population, let's see, and T represent the number of fox population, and T represent the fox population. And in the beginning, it was 19,000. And then the question is find the function NT, but they already give us in the, this is and already given in the exponential form, that is NT is n naught times e raised to rt. So what is this n naught? Is that in the beginning, that means a n naught, and I use the formula. Remember, I always write a is a naught times e raised to rt. So this is my regular formula which I use, but right now this a, because it could be money deposit in the bank or population. I always use this one, but right now they use n. N is the fox population after in the year after since t years passed from the beginning. Now the question is asked, in the year 2013 it was 19,000. So what is 2030? So if it is 0 from 13, oh sorry, it was 19,000. So find the population that models the population t years since 2013. By just knowing, we can use the information with the r's, because in the formula you need to know what is R, and which we already found. This is the R, which is the relative growth rate. And also they give us the number of years. T is given. Uh, so all you do is just put down this one is n t becomes equals n naught is 19,000 and times e raised to r. R is this one 0.09 and t. So that's the first answer. This goes for the first question. That means we have modeled the population of the fox population into an exponential function. So what is the second question is find the function. Use this to estimate. So it says estimate in the year 2021. So that means somewhere in 2021, 2021. So how many years passed since 13 to all the ways 21 is, if you see 2021, if you subtract 13 and you see this become 111, so that will become 8 years. So from here to here, the T is 8 years. Means 13, 14, 15, 16, 17, 18, 19, 20, and then 21. So it's 8 years past. So all you do is you just plug in. So here, just plug in. So let's plug in the second question. So this is 19. So in the year 8, so 8 years, because 21 from 2013 to 2029 is 8 years has crossed. So 19,000 times e raised to 0.09 times, and you put 8 there. And all this you put in the calculator. So let's put this in the calculator and see what answer we get. So if you plug in calculator, and it was 19,000, and then e raised to, so e is right here, raised to 0.09 and multiply by 8, and then you enter. So there you go. You just put click on control and enter, and you get. But the question is, okay, so this is the answer, but then you have to round it to the nearest whole number. But after the decimal, there's a 2, so the 2 doesn't matter. So all you do is this is the correct 39034 is the correct answer. So this answer is 39034 is the population. Okay, so let's check what is the third question is asked. So the third question is, how many years will the fox population reach 23,000? So that means if you want to know when will be, like, we don't know which is, so somewhere here there is the 23,000. So which year is going to be 23,000? So from here to here, all you do is you just plug in this part in the formula. This will be your, we don't know that which year it is, right? But they gave us the fox population is 23,000. So all you do is just plug in this equation. So I'm taking time so that everything is, all steps are understood. So you just plug in, this is 23,000. This is 19,000. And times e raised to 0.09t. Now you can use, of course, I want you to write the steps. So the first step is divide by 19,000. So we have to solve for t. So 19,000. So this 1,000 will go away. This whole thing goes away. And what you have left is 23. So, so this will be 23 divided by 19 equals e raised to 0.09t. Now change it to the logarithmic form. So to change the logarithmic form, the input becomes the output. So now this is the input. So this is the input and this is the output. So when you use the logarithm, now the log that I'm using, okay, logarithm, the base here is e. So I put a e and the output was this. So now it becomes the input. So this is how I get equals 0.09t. That's it. But then logarithm of to the base e is same as ln of e. So I just write natural logarithm, which is, and then divide by 0.09. There you go, 0.9. So all I wanted you to think of the formula, the shortcut formula that I showed in the class is this. This is correct, but if you use, let's say you're using a multiple choice question and you don't have to show the steps. And if the question is asked, suppose A equals A naught times e raised to RT. Remember, there are two more formula directly. Is you want to know the time when certain A, you can write ln of the uppercase A divided by A. You do the log of the ratio of these two and then divide by time. Sometimes they ask you also what is the growth rate, uh, relative growth rate. Then you can also write the same thing. It is the same, this one divided by if the this one is R, but if the R is R, then you put a T. So that's how you can do directly. But if they ask you show the step, this is how you're supposed to show the steps. This crosses R. And then we have to put then ln of 23. And let's check with the calculator. So click ln and then the ratio. Sorry. So here I'll click here and then quotient, and that is 23 divided by 19. And then this whole thing again divide by, so I can just use the this one also and put 0.09 and then control enter and you get 2.1. I think the question is asked to put one place decimal, So after the decimal, there are 1 and then 2. So we can round it to this one as 2.1. So that's the answer. So 2.1 will be the years it will take for the population to. So this answer is 2.1 year for the population to grow to 19,000. That's the question. So the question was asked, how many years will it take for the population to reach 23? So the answer is 2.1. Now the last question is asking, sketch the graph of the population. And they didn't tell us to use the graphing calculator, but the question is, can we use without the graphing calculator? Since we use the number of years is just till 8, so I'll say 1, 2, 3, 4, 5, 6, 7, 8 like this. And in the beginning, the population was 19,000. In 8 years, it was almost 40. So I'll try to get the graph almost maybe ending 45, 50,000 because we got the answer was, I think the first one we got the answer was around 39,000 something like that. I made like a 50,000, let's say. And I break this into 1, 2, 3, 4, 5. So this is 40,000, 30,000. This is 20,000 and 10,000. So because the population in the beginning is 19,000, so it has to start, the graph has to start with 19,000, which will be somewhere here. And the population is growing with the 9%, right? So which is 0.09 at every year, 1, 2, 3, 4, 5, 6. And when it was 8, we seen the population in 2023. So, so when the population rose to after 8 years, so that's what we have seen, right? So it was 8 years was the answer. What did the answer we got? Did I wipe it off? Yes. Remember the second question in the year 2021, the answer was 39,004, something like 39,034. So that means here, if it is 8, 39,000 will be somewhere here. So the population will go increase, right? So it has to go graph, has to go like this. That's it. And you're done. You can just figure out and check. You can also put in the calculator and see, but the question is not asking us to do that, but let's check. Let's check with the calculator. And I'm going to new one and directly put a graph and put down there 19,000 and e raised to 0.09 and x. Okay. And then we'll have to change some, of course, let's enter and you see, you can't see the graph. So I'll have to make this as 50,000 there. Okay. And this side I'll make it like 8. Oh, there you go. We already got this. And this has to be, I don't want too much on the left, right? So minus 10 is not needed at all. So I'm going to make it like minus 1, okay? And see how the graph looks like. So this will be the graph. And you want to know, oh, so this graph, yeah, so that's it. So it's not like, it doesn't go up. I think it goes slowly. And this will be the graph. And I hope I made sense to you how to figure out to get this answer. So let me show the next question. Okay, here they gave you another question. This is question number 7. So question number 7 says graph shows the deer. This time they gave a deer population in Pennsylvania. Count between 2000 days to 4. So you can see this basically means 2004. And this 5 will be maybe, okay, this is 2000. So this is 2010. This is 2011, 2000, sorry, 14. So this is 2011, this is 2012. Not needed, but I'm just trying. So the question is, so you are given in the beginning the deer population was 20,000. So that's all they're asking you. What was the deer population in the year 2010? So the answer is 20,000. Such simple question, right? But the question is, in 4 years, the population, so that means suppose this is the So in the beginning, when it is number of years pass is t, number of years, and this is the population is, we can give a PT, maybe PT, Pennsylvania population, and P also start with this. So it was 20,000 here. One, two, three, and in the fourth year, the population is 31,000. So the question is asking us find the population that models deer population TS after 2010. And now they want this in the form of, they don't want in the form of like how we used to usually write the population A. Let's see, in the beginning you have this time V raised to T. So we could use this if they had not to ask, this is like for in every year. So all you need to know is they give you this will be your 20,000 and you put this as 31,000 and you divide this by 20,000 and then you'll have to do this because in 4 years, so this will be 1/4. So, and you can do that way also, but they are not asking us this part. All you do is just use whatever is compounded continuously. So the population going every second, the population is growing. So this is what we do, and we'll say, okay, PT, the population is n naught times e raised to RT. So, so this n naught, which is the beginning. So in the beginning, the population was, this is n naught. So that's, so this is, I'll take this off, and this will be 20,000. So no issue. So that is 20,000, right? But then the population has risen to 31,000. That means if when t equals 4, that means from here 1, 2, 3, and 4, and then I put this as 4, so this will be, this whole thing is 31,000. See? So all you do is work, you can do directly with shortcut formula that I gave and say, hey, R is 31 ln, so you have, because there's a E basis, so ln of 31 divided by 20, because this 3,000 will go away, and then divide by 4 and you can get the answer. But let's get the exactly how did we get this is so this one is 4, so let's put the t there. So this is 31,000, this is 20,000 times e raised to r is what we need to figure out what's the relative growth rate, and times 4. So now divide by 20,000. So 20,000, and clearly see we can reduce this, make it smaller, simplify this, dividing by 1,000 on the left side, and this 20,000 crosses out. What are you left with is only 31 divided by 20 and equals e raised to r times 4. And then you can apply ln both sides. So there is another way to say just apply ln and ln both sides here. So this will be ln of e. So what is ln of e raised to, let's see, p is always directly p. So this becomes ln of 31 divided by 20 equals r times 4, and then divide by 4, and you put this in the calculator, this 4. So now you know how to put this in the calculator, and you will see the answer you will get is so you get is 0.1096. So 0.1096. And you want to confirm this, I think we'll have to put that 31 divided by 20. Let's see again. Where is that? So if I want to put a calculator and directly, let's see, so ln of, and then we have 31 divided by, what is that? 31, I forget. Yeah, it was 31 divided by 20. So 31 divided by 20, this is 20. And the whole thing has to be divided by 4. and control enter, and you get that. See the same question because they're asking you to round it to the nearest thousands. So thousand means this is tenth, hundredth, thousand, and 10,000. So you have to round it to the nearest thousand. So you have to round this five, this five will have to be increased to six. So it is 0.1096. So this is zero. That's how you get 0.1096. So this B will be equal to this population. Oh, they give you NT and I wrote PT. Okay, so that's fine. So this is 20,000 e raised to 0.1096. Okay, and you're done. That's it. And the next question, number C, is also asking us what is the projected population if it were in the year 2023. So if you see this, if I want to go this still continue going in the year 2023, this was 2010. So this is 2010. This was 2011. This was 2014, and they're asking you what is the population in the year 2023. So 14, 15, 16, 17, 18, 19, 20, 21, and 23. So 2023. So that means from here to here, 2023, if you subtract this, you get 13 years. So all you do is put 13. So in the formula, you go down. So this answer, the C answer, you want in the year. That means here T becomes 13. So the population in 2023, sorry, 2023 will be 20,000 was the population in the beginning, then e raised to 0.01096, and you just multiply by 13 and you get the answer. The answer they want is nearest two decimal places. So let's see if I have this, and right now I just put ln of 20,000 e raised to the power 0.1096 times 2, and just click Control Enter, and you get that 31,000. So you get the answer is yeah. So I have to go back. I think it is 13, right? So I put it like 4. So this should be 13 there. Sorry. This should be 13, and then you multiply by, sorry, 0.1096 times 13. And now click on Control and Enter. You get 83,000. And you have to round it to the nearest two places. So I'll have to increase this 2 by 1. So that way it becomes 83. They want the answer rounded to the nearest 1,000. So this one is showing you 283140, but they want to round it to the nearest 1,000. So I'll have to write this answer. So this answer that we got is 83140.527. Now nearest 1,000 will be this is ones, tens, hundreds, and thousands. So you have to round it to here. But then after this, it is 1, which is less than 5. So this doesn't matter. All you write is 8, 3, and the rest of the 3, this part you put 0, 0, 0, and you're done. And the last question is, so the next question, there's another question. So the question is, after how long will it will take the population to reach 500? So the formula that we modeled was 20,000 times e raised to 0.1096t. So this will be put 500,000 and then this is 20,000. So all you do is divide by 20,000. So this will be, this 1,000 will go away and this whole thing will go away. And you have left with E here, which we can directly write it as applying ln both sides. So let me wipe this is not needed and now change to the logarithmic form. So it's like if you have e raised to x is y, x is ln of y to the, that's it. This is how it is. That's because x is logarithm to the base e of y. Whatever the input here, this is the input becomes the output here. Sorry, this is the input, now it is the output here. So when you're changing from exponential to a logarithmic form, the input becomes the output and the output becomes the input. So that's all it is. So you can directly write, so okay, you want to know this is the input and this is the input. So this becomes the output. When I write output, I write 0.01, sorry, so it is 0.1096t, and this is 500 divided by 20 ln of, when you're writing in the log form. And then divide by 0.1096 both sides. You will be getting the answer as 2937. You have to round it to the nearest. I hope this makes. So this, even though it took me 26 minutes, okay, I did only problem number 5, 6, and 7. Tomorrow I'll try to do 8, 9, and 10. See you guys. I hope you will continue working on this.